independence, it's the same probability tree as the last one, but I've actually added a bit of notation. So here we've got the conditional notation here. So when home or not at home is the first branch, winning or losing is the second branch, but we've changed it here. We've given this as actually a conditional probability. Actually, that 0.65 is the probability, not that they win overall, it's the probability they win given that it's a home game. So we can write it as a conditional probability. And then we can write them all. So the second one down, the 0.35, is probability of not winning given that it's a home game, and so on down through. So we can write them with a slightly different approach, just using slightly better notation. Now, if the question is, and this has come up in exam questions, are the two things, being at home and winning, independent? Now, the short answer is no, because the probability of winning changes whether they're at home or not, so it's clearly a factor. This team does win 65% of their games at home, whereas they only win half their games when they're away from home. So on one level, we can answer it like that. So the answer to this is an interpretation thing, but it comes up in exam questions. So we say, well, the probability of winning at home is 0.65. And we worked that out in the previous question. Probability of winning overall, this is the overall, is 0.56. And so because those two things there don't equal, then they can't be independent, because we're saying the home or away business impacts the ability to win. Okay, and so that's more of an interpretation thing. We really didn't have to do any calculations, but we're getting the logic and the term of independence sorted and being able to articulate it simply to the exam.